here. All right. This is fundamentals test 6. All overhead valve engines. What? Use an overhead camshaft. Use the camshaft to close the valves. Are operated by the Wankel cycle. Have the valves located in the cylinder head.
I said D.
Okay, now this is the nomenclature. Even if you call the parts store, they're going to say it's an overhead cam or overhead valve. Well, even on overhead cam engines, where are the valves?
In there.
In the dadgum cylinder head. Now, the engines like the old flathead engines, like they used to have on the lawnmower, like Briggs and Stratton lawnmowers used to have, had the valves in the block. Well, Briggs and Stratton lawnmower engines were flathead, and like the flatheads in the old Ford pickup trucks way back in the 50s, they had the valves were in the block, and the combustion chamber, it's just a strange deal. The spark plugs were in the head, but there were nothing. The head was nothing but a piece of iron. Is all it was. They didn't have any springs or valves or nothing. All of that was built into the engine, and all that. But I mean, why they call an engine that doesn't have overhead cam, overhead valve, is beyond me. I don't understand that. So that should be D, but I don't like that question, and I don't like the way they do that at the parts store. You call a parts store, they'll say overhead cam or overhead valve. And somebody somewhere came up with that, but I don't know who it was. SOHC V8 engine has how many camshafts?
2.
It's got one on each head, right?
Mm-hmm.
Okay. The coolant flow through the radiator is controlled by what? What?
The water pump.
What?
That's what it said in the book.
Thermostat.
Thermostat. The book says thermostat. It doesn't say water pump. You didn't read the page yet enough. Second rate amateur. All right. Find me in the book. If you can find me in the book where it says the coolant flow through the radiator is controlled by the water pump, I'll give you credit for the question. And he's a flipping.
I read this.
Yeah.
The water pump circulates the coolant
Through the radiator.
I know, but it doesn't control the flow. Right? Where's the answer you found?
Sir?
Where's the answer you found? He said as he changed his answer? He just changed his answer.
I know, I circled both of them, and I meant to circle the bottom one on the first one.
Yeah, he had both of them circled.
Okay, I see. So you alerted him that he had circled 2 answers, which by default is a missed question. Mark that wrong. Okay.
The temperature is controlled by the thermostat.
That's what it says in here.
Yeah, the coolant flow through the radiator. Now let me ask you this: where is the thermostat
Generally
in relation to the radiator?
Generally on where the water comes out of the radiator.
Where the water comes out of the block.
Right.
Okay, so if the thermostat's closed, no water's going to go through the radiator.
Right.
The water pump is going to pump the water where when the thermostat's closed? Talk to me, Mr. Kendrick. You're right. It goes through the heater core. It bypasses through the heater core. Now, some of them used to have a hose that would just bypass the thermostat. So the water pump could continue to circulate the water through the engine, but they don't want it in the radiator. Why don't they want it in the radiator right to begin with? I mean, they don't want it going through the radiator.
They're trying to get the water to warm up.
They're trying to warm it up so you can have cabin heat. Also, the quicker the engine gets warm, the more efficient it is. And the engine needs to run about 200 degrees, 200 to 210. Do you know when the fan comes on like a 97 Cavalier, what temperature the PCM turns on the fan? 228 degrees.
My truck runs about 130, 120.
Yeah, that's bad for the engine, and it will wear it out really fast, and you'll have an engine that burns the wall and all this kind of stuff. So,
It does all that.
it erodes the metal away, like 95%. I read somewhere that 90% of engine wear is due to sulfuric acid content in the oil because of the sulfur in the fuel and all. But what you wind up with, if you make a gallon of water for every gallon of fuel you burn. And the PCV system is supposed to pull that out of there, right? If your engine's running too cold, you get a lot of condensation in there, and that turns into sludge. You see that sludge, that old thick crud that's inside an engine when you pull up? That's because you got one, either Granny and Grandpa drove it to the store and back and didn't get it warm, or it was like yours, it was running really cold, which is bad. It's not good for it to run really
We
cold.
put any other thermostat in it, it runs hot, so we have to keep a low temp thermostat in it.
Yeah. A low temp thermostat, 130 degree thermostat. Wow. Okay. Torque is expressed in units of what?
B.
That's B. Pound feet. Now, I will tell you this.
So
if
hang
you're,
on.
if, yeah.
Did we establish that A was wrong on number 3.
Number 3, it was a little bit confusing, so you don't actually see the words, the coolant flow through the radiator is controlled by the thermostat, do you?
Right.
Just remember that that's the truth.
Alright.
It does too. It says the coolant temperature is controlled by the thermostat, which opens and allows the coolant to flow through the radiator.
Whoops.
When temperatures reaches the rated
Where
temperature
did you
of
see
the
this at?
thermostat.
Where are you seeing this at?
130.
Figure 14.
See, there's where he's,
He was looking, sometimes
looking at
if you look at the
something different.
captions under the pictures, you'll see answers.
I look at all of it.
You know what I mean?
the coolant, okay, see, now if I would've saw that, I would've picked the right answer.
Yeah,
But I was
okay.
reading cooling system.
So we have determined that the book did,
Okay,
that
it's
Mr.
wrong.
that James Haldeman wrote the book right whenever he put that in, okay?
Okay,
All
we're
right,
apologizing.
so, torque is expressed in units of pound-feet, but, you know, that $500 torque wrench, that snap-on torque wrench we got out there, if you look at it, it says pound-feet. But if you say pound-feet in a shop full of mechanics, they'll say, where did this idiot go to school? Nobody says pound-feet. They say foot-pounds, you know? I argued with a guy about that one time, and he goes, no, it's pound-feet, it's pound-feet. Well, if you say pound-feet in a shop full of mechanics, they'll think you're a dummy, you know? I mean, you need to kind of sound like you know what you're talking about, because everybody else says foot-pound. Horsepower is what?
B.
What's that? A and B. A measurement of engine power and calculated as torque multiplied by engine speed.
Leave it to someone like me.
5,252.
Get that wrong.
Yeah. Yeah, if you got sometimes when I'm going through tests, like if I'm taking a test really fast, I have a tendency to machine gun the questions, and I'll read, and the first right answer I'll put, and sometimes I'll hit it, there'll be an all of the above, and I'll get it wrong.
Well, it just seemed like A was too simple to be right.
Well,
It was just too
a
easy.
measurement of engine power. Well, it gets A and B, but apparently it was simple enough to where you got it wrong. So.
Exactly.
No,
Okay,
I
what-
just thought that, well, that's simple and it's probably right, but that's probably not the answer you want
Well,
because it's that simple.
It's the truth,
Right.
though. It's a measurement of engine power, but it's also calculated as the torque multiplied by RPM by 5252. One cylinder of an automotive four-stroke cycle engine completes a cycle every what?
180 degrees.
Now, wait a minute. Completes a cycle. Did it say completes a stroke?
Oh, that
If
would
it
be
well, then if that's
Completes the cycle
360,
means,
no,
uh,
Is it?
Intake, compression, power, exhaust.
360.
No.
It's gonna be 4
Intake-
times 180.
That's right. Which will be,
If I,
huh?
It's gonna be B, ain't it?
It's gonna be 720.
720, yeah,
That's right.
okay, that's,
Yeah, but I mean, strokes are, what I was wrong, strokes completed in 180
so
degrees.
that's a stroke.
Yeah, a stroke is a stroke is from the top to the bottom, but you gotta have, you got intake, compression,
You got
power,
4.
exhaust.
Good Lord, I
Right.
You know, and that's gonna be, that's why if you take the number of cylinders an engine has, like if it's a 4-cylinder, you divide that by 720, and 4 to 720 is 180.
Right.
And if that's how many firing events you have. Now think about this, you were talking about diesel a while ago. A gasoline engine, the fire is all burned out by about 25 degrees after top dead center. So that means on a gasoline engine, you're just slapping the piston. You know, imagine yourself turning a crank to make something happen, and you just slap at the crank. You slap it at exactly the right minute. You know exactly when to slap it. On a diesel engine, because the engine, the fuel burns all the way down, you're pumping the crank. You're pushing it all the way down. And that's why a diesel engine's got such legendary torque, more than a gas burner does. You see what I mean? But anyway, all right.
Hey,
On a 6-cylinder, you got 120 degrees between firing events, and on an 8-cylinder, you got, 90 degrees. All right, so, let's see, rotating force is called what?
C.
That's torque, that's not complicated. Technician A says the crankshaft determines the stroke of an engine. Technician B says the length of the connecting rod determines the stroke of an engine.
The length of connector.
What
well,
determines the
obviously
stroke?
can't both be right.
They can't both be right.
Would it be technician
A.
A? Because your connecting rod, just like on that one, you make half a turn, it's still gonna drag the piston halfway down.
So the length of the throw on your crankshaft, which
Right.
would be from the center to the
that.
center of this, from the roof of your, it's like, well, the stroke, what you got, if you got a crank, you ever turned a crank on something? All right, the longer the crank is, the more your stroke is, and the shorter the crank is. Think about this, you got an engine that's got a little piston and a long rod, that's under square. And what it does, it's got lots of torque because it's got a long connecting rod, and it's gonna typically have more of a stroke to it. So, you know, you basically are measuring the bore and the stroke and comparing them to one another. So if the stroke is really long and the bore is really small, you got lots of torque, but you don't have lots of revving speed. But if you've got a big piston and a little short stroke, it revs really, really fast, but it ain't got a lot of torque. You know what I mean? That's over square. Over square is when your piston's bigger than the stroke. You got where I'm going? If it's got a 4-inch stroke and a 3-inch, a 4-inch bore and a 3-inch stroke, it's over square. That's what they call it. If they're the same, it's square. You know, so anyway. How many degrees of camshaft rotation are needed to complete the 4-stroke combustion cycle? To complete the entire cycle, how many?
D, 720.
A, 360. It's half, the camshaft turns half as fast as the crankshaft, okay?
That's why I put camshaft in bold, so you wouldn't get it confused.
Can we start doing this on Tuesday mornings?
Yeah. Are you still getting over the weekend or something?
No, it ain't getting over the weekend.
I would like to know which one of those knot heads
Monday
busted the rings that were on my new piston on there. All right, so that wasn't y'all that did that, it was some of the other group.
You beat it up.
Yeah, all right, so
morning.
how is diesel fuel ignited in a warm diesel engine?
That would be heat of compression.
Heat of compression, you're squeezing it, you're getting 2 degrees per pound of compression, and you squirt that, you miss that fuel in there, if you got 1,000-degree air, it's gonna light off. Number 12, which diesel engine system requires the use of a glow plug?
Direct injection.
Indirect injection. I will tell you this though, the Cummins engines don't typically, you know, a lot of them didn't use glow plugs, they just used like a manifold heater. Some of the older Ford tractor engines had a little thing in there that was like a cigarette lighter with fuel going to it, and it would get really warm and it would trickle a little bit of fuel in there and start a fire in the intake, and that would make it start good when it was cold and all that. So there's a bunch of different ways they've dealt with that. You know what they first, Rudolph Diesel, he actually first started experimenting with compression fired engines, and you know what fuel he used?
Yes.
Huh?
Yeah.
Coal dust.
Oh, good.
Coal dust. He was blowing coal dust in there, letting it light off. And I wrote an article. I was writing an article for one of the magazines I write for about diesels, and I went into some history of diesels, and that's one of the things I discovered when I was doing research for that, was that coal dust was what he used initially for the fuel. And this guy that said this foreign exchange student that's from Germany, you know, diesel is a German deal, and he said that a lot of this guy died kind of mysteriously. A lot of people think he was murdered, that Rudolph Diesel guy. I didn't know that. I mean, I hadn't never really studied Rudolph Diesel a lot, but I thought it was interesting that foreign exchange student was talking about that. But
That foreign exchange student gets his work done.
he's really, really smart, and he's really tough. And when you give him something to do, he don't stop until it's done. He don't care how dirty he gets. He don't care how hard he has to work. He don't care how long it takes. That's a working his son of a gun. But I've seen this side of the water. Man, that guy will work up a storm. And the harder the better. I mean, the harder the job is, the better he likes it. And he doesn't ask for help either. He just keeps on plugging, you know. I like that guy. But, all right, let me see. Let's see, what fuel system component is used on a vehicle equipped with a diesel engine that is seldom used on the same vehicle when it is equipped with a gasoline engine?
Be water fuel separator.
Yeah, you're gonna have to have a water fuel separator on a diesel motor. And you know, when it gets really, really cold, diesel tends to turn into jelly too.
Yeah.
Back in 1985, it was 1 below zero. One morning. I don't remember what the day was. It seemed like it was New Year's Day or something. I can't remember. It was really right and it was an odd time of year. I mean, usually in this part of the country, we don't have our coldest weather until February and March.
Right.
You know, I mean, I remember when I was getting off the school bus when I was in like the 6th grade, it was almost Christmas time and it was 60 degrees outside.
Sweating your tail off last year, about
Yeah.
80 degrees.
Yeah, I know, but anyway, that was the, but long and the short of it was, I started to say, I was working at a truck shop then, where we did big trucks. It was a place that sold international trucks, and also they had international lawnmowers, so everything I worked on, with some exceptions, was either a lawnmower or a tractor trailer. The littlest and the biggest. And of course, sometimes I work on an international scout, you know. But anyway, I had to go out there when it was really, really, really cold and get a whole bunch of trucks started all over town. And some of them, their air brake systems were froze up because they had water in their tanks and they couldn't, you know, use the brakes and all that kind of stuff. And that was a very cold day, 1 below zero. I still remember that. Diesel injection pump is usually driven by what?
D.
Gear off the camshaft. Usually gear off the camshaft. Interestingly enough, the high pressure oil pump on Power Strokes is driven by a gear off the camshaft, and also the injector pump, well, on the old 7.3 was driven that same way, and on the Duramax, is, you know, the high pressure fuel pump driven that way. Which diesel system supplies high pressure diesel fuel to all the injectors all of the time?
D. High pressure.
High pressure common rail, and that's what your grandfather's Duramax has on it. You know what the fuel pressure that tops out at on that thing? 23,550 pounds.
Good.
You talking about the pressure of
Yeah.
You wanna fill an air tank pretty quick.
Yeah.
just-
Well, when it's idling, it's usually running 4,000 or 5,000 pounds of pressure, but whenever you're really standing on it and it maxes the pressure out to 95% of that.
I've stood on it
Yeah,
a couple
it's-
times too.
Yeah, yeah, those things are, that thing is, that system is a consortium of between Bosch and I think Isuzu and some other people, you know, they're with GM and all. Which of these takes place during, one of the things I like about the turbocharger on a Duramax is it's exactly like the turbocharger on a Power Stroke of that same year model, same one, variable geometry turbocharger, but the Duramax turbocharger got stainless steel parts, which I thought was pretty cool.
Yeah.
And also the Duramax turbocharger has got a sensor, so it's a feedback sensor riding off of a cam in the turbo vane, so it can tell where the position of that thing is. Now only that same hole is there, it's made by Garrett, the turbocharger is. That same hole is there, as I remember it's made by Garrett, maybe made by somebody. Anyway, screw that plug out, you can see that cam where the Chevy sensor rides, and you can watch it. So it's an all driven thing, driven by oil pressure. Anyway, that's a long story, that's another class. Okay, let's see, which of these takes place during regeneration of diesel fuel in a diesel particulate filter, DPF?
D.
Soot is being burned, it gets rid of the soot. Got it? Selective catalytic reduction, which is SCR, uses urea injection.
A.
That sounds like you're talking about fertilizer, doesn't it?
A.
To reduce emissions. Yeah, NOx emissions. You want what's NOx emissions, by the way? Anybody know what NOx emissions are?
I've no clue. Probably I got it wrong.
Nitrogen is most of what we've got in the air around us out here. This air is only like 21% oxygen, it's 78% nitrogen, the rest of it trace elements, right?
Yep.
So what is it that expands whenever you have your explosion in the combustion chamber? The nitrogen's inert, it doesn't burn, but it does expand. So nitrogen's what pushes the piston down because it's expanding because of the heat, right? So the explosion of the oxygen and the fuel together heats the nitrogen up, and that's what pushes the piston down. You may not hear that anywhere else, but that's what's going on. You know, because most of the time they don't even talk about that. They're saying, well, the explosion is what pushes it down, but it heats up the nitrogen, so that's what's of it. However, if it goes over 2,500 degrees in a combustion chamber, the oxygen and the nitrogen lock together in these screwball compounds. The reason they call it NO with a small x is that x can be just about any number.
Right.
All right, so the catalytic converter, well, to begin with, you take some inert gas from the exhaust, it won't burn, and you cool the combustion chamber off by putting unburnable gas in there with your EGR. And on the diesel engines, you run it through coolers. And on the, some of them actually are measuring the temperature of the exhaust going into the EGR cooler and coming out. And so whenever that goes in there, it's like you took away some of the, you know, when I was working in oil patch country down there, if we were gonna, let's say we had a barrel that had some explosive stuff in it, have gasoline or something that would blow up in it, and we needed to get a torch and cut that barrel in two. That sounds dangerous, doesn't it?
Mm-hmm.
Scare the daylights out of you. Well, you know what them Cajuns did down there? They would take a pipe and a hose and stick it on their tailpipe on their pickup truck, and they'd shove that hose into that barrel, and they would just let it fill it up with car exhaust. On a truck that was running right. And that car exhaust was inert, it wouldn't burn. So if there's no oxygen in there, all the oxygen's been purged out of there. And they would just burn that barrel without any kind of danger at all. You ever wonder why the fuel pump in the gas tank is an electrical motor that's spinning with those brushes? And brushes, usually when you got spinning brushes, they make little sparks, right? It's in the gas tank. And that gas is flowing right through that motor, right past those brushes, right past that spinning armature. That sounds spooky, doesn't
Yeah.
it? But it never
Spark
blows
won't
up.
light.
They were
Spark
doing that in
won't light
aircraft for
gasoline.
years, huh?
Spark won't go like gas.
Yeah. What's the first vehicle, the first vehicle I ever remember that had an electric gas fuel pump on it was the Chevrolet Vega. It had an electric fuel pump on it.
Never had a cigarette light gas either.
Huh?
Will a cigarette light gas?
It will light gas in some circumstances. Basically, if you've got a can of gas, it's got some vapor in it above, like if it's not full and there's vapor there, if you thump a cigarette in that, something will go boom. But if it's all the way full, if you thump a cigarette in there, it'll usually go tch.
Yeah. But if
Well,
you
if
pour
you
it
get
on the ground, then you put a cigarette on it.
If you get a torch, like we lit up this torch out here to show you guys how to use a acetylene torch, and you pop the flame out, we get a neutral flame, and you just put it down on the bench and you pop it out, and the flame goes out, and you fill a balloon up about this big with it, and put it out there somewhere. Somebody throws a cigarette on it, it will rattle the windows a half a block away. I mean, it's like a bomb going off. And this one guy was saying at the dealership over there, this one guy at the delership over there, don't get hurt. This one guy at the dealership, he says, I've heard about this, but I don't believe it. So I put some gas, about big as my head, out there in the parking lot of the dealership, and I threw a cigarette on it. He was standing 50 feet away, and he said he felt a shock wave go by his hair. Boom! It was like, there ain't no fireworks you've ever heard is any louder than that, man. It
How
scared
do
the
you
hell out
throw
of
a
me.
cigarette from 50 feet away?
Yeah. He didn't.
was.
I was the one that threw the cigarette. He was standing over there.
Yeah, I imagine
And,
it's probably.
and you could literally feel that shock wave. It's like shooting a 44 Magnum. Boom! You know how you feel the pressure on your face.
That, I don't know.
Yeah. But anyway, all right, where are we at here?
18.
This diesel engine is what type? This diesel engine is what type?
Injected.
And that's going to be
Indirect, that would be B.
18 is going to be B. That is indirect injected, which is like the older ones. Here's something else I'm going to tell you about diesels while I'm talking about them. Whenever you've seen the diesel engines that had the injector pump with all the lines snake into the injectors. All right. One time I drew a diesel engine that I was working on that was in some kind of a piece of equipment or something, and it was misfiring on number 1 cylinder. Well, I noticed that something had happened to the injector on number 1 cylinder, and so they just took a piece of tubing and that was really strong, that was made out of the same stuff, and they put the fittings on the end of it, and they just ran a line from the injector pump straight on up to the injector, and that was the one that was misfiring. You know why it was misfiring?
Probably because
It was not the same length as the other lines.
really?
It has to be exactly the same length as the other lines. That's why you see those lines looking like
Snaking around
spaghetti.
everywhere.
They don't just run lines straight to the injectors. Every line, when they start out, before they start bending them, has to be exactly the same length. And you cannot bend them in a radius that's tighter than 2 inches usually. See what I'm saying? And they also, I'll tell you something else they do. You'll see these little clamps that's got those lines clamped so that they actually can't wiggle and move. Any little thing can affect that pop on that, that injector, how it pops. And so that's basically what, those lines have got to be the same length, and they can't be bent any sharper than like a 2-inch radius, and they also have to have them clamps on them where it holds them. So there's a heck of a lot more to that diesel stuff than you think because of the timing of the pressure wave that goes through that line and all that.
Carburetors use a lot more.
That's another thing I learned when I was researching that article on the diesel. Of course, I'd worked on a lot of diesels too, but when compared to a gasoline engine, the diesel engine may be what?
A.
Heavier. Why? It's just typically more robust. It's a little heavier built than a gasoline engine usually.
Takes more.
Yeah, there you go.
Got more power to
Yep.